Hello and welcome. In this video, we are going to look at what exactly Apache Spark is. In rest of the videos that I'm going to record in this series, we will do a lot of hands-on coding along with understanding all the concepts that are required to be a master at Spark. So let's quickly look at what exactly Apache Spark is. So Spark, as per the definition, is a large-scale data processing engine. Basically, it's a framework that helps you process huge amounts of data with ease. It's conceptually very similar to MapReduce. If you are familiar with MapReduce, you will be very easily able to connect with Spark. But technically, it is different. It is much better than MapReduce in terms of performance. We will look at how it is better than MapReduce in terms of performance. But from use case point of view, both MapReduce and Spark are built for helping process large amounts of data. It basically lets you focus on your business logic, which means that things like how to distribute your processing on multiple machines, how to parallelize your processing, they are taken care of by Spark. All you need to do is focus on your business logic. So just to give you an example, let's say you just want to figure out, let's say, top cities where your sales are happening from the sales data, right? Now, the business logic is very, very simple. I mean, you simply aggregate all the sales based on the cities, and then you sort them, and then you pick the top cities, right? So the business logic, if you just want to write it for, let's say, sales records that are, let's say, thousands in number, right? You can simply write a very simple program either in C, C++, Java, or any language of your choice, and you'll be able to do it like in minutes, right? But the problem comes when the data size is in millions or billions, right? What happens is if you write that simple logic in a simple program, it's going to take hours to run. And that is not something that you would want, right? If you want to run that report, let's say every day, then it's going to take a lot of computing resources just to figure out the top cities where your sales are happening. So that simple logic is not sufficient in that case. Now, what Spark does is it lets you write that simple logic the way you would have written it in a single threaded simple program, right? But then Spark takes that logic and then it will distribute it to multiple machines, and it takes care of where your data is present. Let's say if your data is present on a distributed file system, it takes care of that data locality, and then it will process the data at much faster pace than it would have been in a single threaded program. And you don't need to worry about any logic that is required to distribute that processing. So Spark is basically helping you parallelize your processing much efficiently. All right. At a very high level, this is the architecture of Spark. I won't say this is the architecture, but this is a 15,000 feet view, where the main things that Spark consists of are. So this is the driver. This is basically the program that you are going to write, where you are going to write your business logic, and then it takes help from a resource manager. The resource manager could be Yarn, or Spark has its own resource manager as well. If you want to learn more about a resource manager like Yarn, I have another video. You can search that in my channel, and you can understand each and everything about Yarn. But then Spark takes help from a resource manager, and then there are a lot of data nodes or worker nodes where Spark is going to run the logic, right? And on every worker node, there are executors that are going to run. In every executor, Spark is going to schedule some of the tasks with the help of the resource manager, obviously. And then there is some cache that can be used to provide, let's say some kind of information basis or data to all the executors, which can be used by the tasks. So this is a very high level view. We'll obviously dig deeper into what exactly the architecture of Spark is in next sessions. But at this moment, just for the introduction sake of point of view, this should make sense. Okay, directed acyclic graph. So in the first slide, we discussed that Spark is much faster than MapReduce. Now, DAG, this is one of the reasons why Spark is much faster than MapReduce. Obviously, there are other reasons as well, like Spark runs in memory and MapReduce runs a lot of operations on disk. But DAG is one of the big reasons why Spark is faster. So basically, what happens is when you write your business logic in your driver program, right? Your business logic is nothing but a kind of a workflow where you define the steps that you need to take in order to process your data. Now, what Spark does is it does not actually execute any of those steps in series, just the way you have defined them. What Spark is going to do is it will take all the workflow that you have written in your driver program, and then it is going to optimize it. Then it's going to run it at once in an optimized way so that, there is no extra processing of data happening in order to arrive at the same result. In other words, Spark is using its own intelligence to optimize your workflow. And that intelligence is basically called directed acyclic graph. Basically, what Spark is doing is it is kind of creating a graph of your workflow, of all the steps in your workflow. And then it is figuring out, okay, in order to arrive at the final step in that graph, what are the middle steps that it can optimize, right? And DAG is at the heart of the speed that Spark provides. Now, when it comes to using Spark for writing your applications, there are multiple options that you have. In terms of coding language, Spark jobs can be written either in Scala or in Java or in Python. Scala is the best amongst them because Spark itself is written in Scala. Scala is a functional language. And if you do not have any experience with Scala, I would suggest that you at least watch one or two videos on basics of Scala programming. You don't need to be an expert in order to use it for writing Spark jobs, but then you need to be familiar with functional programming at least. I will try if I can record one video on basics of Scala programming, which can be helpful in understanding Spark even better. Then there are higher level APIs using the SQL based on datasets and data frames. So basically, in earlier versions of Spark, there was only lower level APIs that were using RDDs, resilient distributed datasets. I'm going to record next video on resilient distributed datasets because it is one of the most important topics in Spark, in learning Spark. But in earlier versions of Spark, RDDs were the only APIs that were available for developers. And they are basically lower level APIs where developers need to take care of a lot of things when designing their business logic. But in the later versions of Spark, there are a lot of higher level APIs that are based on SQL, and basically they make use of data sets and data frames. Internally, these data sets and data frames are making use of RDDs only, but then it makes the job of developers much easier to use these higher level APIs. It doesn't mean that you can live completely without RDDs. RDDs are still very important because there are a lot of operations that cannot be described in terms of SQL. And higher level APIs, and for that you will be using lower level API using RDDs. But then you have a lot of options. If your business logic is simple that can be described in terms of SQL statements, then definitely higher level APIs are going to be recommended. Don't worry about details of these things as of now because I'm going to cover each and everything in the future sessions. We'll get into details of each and everything like data sets, data frames, RDDs, right? These are the Spark components at a very high level. So at the base, it's Spark core, the core engine of Spark, and RDDs also lie at this layer along with the Spark engine. As I said, RDDs are at the lower level APIs. And on top, Spark has provided different components to make the job easier for developers, like Spark Streaming. It's a very good framework if you are going to process, let's say, streaming data. If, let's say, a lot of logs are coming continuously to your system and you want to process them at sub-millisecond latencies, then Spark Streaming is your choice for that. Spark SQL, as I mentioned in the previous slide, Spark SQL is going to make use of data sets and data frames. And it's basically a framework which lets you visualize your data in the form of RDBMS tables. and then you can run SQL queries on those tables and get the results. It doesn't mean that Spark is going to store that data into RDBMS. It just means that the view that you get of your data is in the form of a table. But internally, Spark is going to use RDDs to do that processing, which means it's going to be very, very efficient. There is another layer at this another module at this level, which is called MLlib. Is basically for data scientists. It contains a lot of libraries of machine learning that can be directly used by developers to write their jobs that need to use machine learning algorithms in their jobs. Basically, earlier data scientists were using simple Python programs to write those machine learning applications, but they were not very efficient because it was very difficult to parallelize them. And generally, machine learning applications run on huge amounts of data, and Spark has basically taken care of that. It has parallelized many of those machine learning algorithms. It does not contain everything that machine learning people would need, but then it contains a lot of good algorithms that have already been made available in the form of Spark MLlib library, which can be used by machine learning developers. There is another not so much used module called GraphX. It's basically to help those developers that want to create use cases that need graph processing. For example, social networks and data that contains relations between different entities. It's not really widely used as of now, but then again, it's something that's available if you have a use case which requires graph data processing. We are going to look at details of each of these modules in the future sessions. So that's all about introduction to Spark. If you have any questions, please write that in the comments, and I'll try my best to answer. I'm also ready to record videos based on your requests. If you have any requests, please write them down in the comments, and I will try to help you as much as possible. Thank you so much.